And welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 50, POW_xn. Implement POW_xn, which calculates x raised to the power n, i.e. x to the n. So what does this mean? So what if we're given x equals 2 and n equals 5? Essentially, what we want to do is calculate 2 to the 5th. So how can we do this? Well, remember that 2 to the 5th is just 2 times itself 5 times. So this would be 2 times 2 times 2 times 2 times 2. So this is 4, this becomes 8, this becomes 16, and this becomes 32, which is our final answer. But notice here that we had to multiply 5 times, right? So the amount of time it's going to take to actually calculate this is going to be big O of n. And while this works, it's the naive solution. And here's the reason why. If you remember from your math class, what can we do with exponents? Well, with 2 to the 5th, we could rewrite this as 2 to the 3rd times 2 to the 2nd. And that's the same thing, because remember with exponents, when the base is the same, you can add the two powers and then just do 2 to the 5th, or you can decompose it to 2 to the 4th times 2 to the 1. Well, if we look at 2 to the 4th times 2 to the 1, we can also decompose 2 to the 4th. So we can say 2 squared times 2 squared, and then we have the 2 times 1, right? So if we have our function to calculate 2 squared, then we don't have to calculate it again for this one because we already know the value. So what we want to do is we want to break down our exponent as far as we can go until we hit the base case, which is either 2 to the 1 or whatever our base is to the first power, because remember, anything raised to the first power is always just going to be whatever the base is, and anything raised to the 0th power will always be 1. So those are our base cases when we have an exponent of 0 or 1. Otherwise, we're going to keep breaking down our power each time by 2, and we're going to store this in some sort of memo dict. So that way, for example, we have 2 to the 4th. We can decompose it as 2 squared times 2 squared, but we can figure out the value of 2 squared, and then we can just reuse that value from the memo dict instead of recalculating it, because that's going to be expensive, right? And then we can further break this down to be 2 to the 1 times 2 to the 1, and these are our base cases, so we get them very quickly. And then this 2 squared here, we can just reuse the calculation from the memo dict. And what this is going to do is actually it's going to allow us, because we're breaking down our solution by 2 each time, we can bring our complexity down to be log of n, because we're basically having the problem space each time. Now, with 2 to the 5th, it's a little bit tricky because it's an odd exponent, right? So when we have an odd case, what we want to do is we want to basically remove 1 so we can get an even, right? So we're going to say this is really 2 to the 1 times 2 to the 4th. This one we can't really break down anymore because it's already in its simplest case, but this one is now even and we can divide this evenly, right? You can't divide 5 evenly. You get 2.5, and we don't want to work with fractional powers. We want to work with even ones because that way we can just keep dividing by 2 each time. So when we have an odd, it's going to be 2 to the 1 times 2 to, whatever our previous power was, minus 1, so 2 to the 4th, and then this one, again, we can decompose into 2 squared, and then this one we can decompose again. So that's how we're going to solve this problem, and we do have to be a little bit careful about negatives, which we'll take care of. But that's essentially what we want to do, and like I said, we're going to bring down our time complexity down to log n, where previously, if we were just multiplying it through, we would get big O of n, and this is the answer that your interviewers are looking for, that you can kind of decompose this and write some sort of recursive solution with memoization. Anyway, that's enough talking. Let's go over to the code editor and see how we might code this up. Welcome back to the code editor. Let's type this up. So the first thing that we want to do is actually take care of the case where we have a negative exponent. Remember that when you have a negative exponent, it's the same as a positive one, except for the final result is going to be 1 over whatever the result if the power was actually positive. So for example, if n equals 2 and the base equals 2, then it's 2 to the minus 2, which is just 1 over 2 squared, right? Which is 1 over 4. So that's how we want to do it, and we need to actually know whether or not our exponent is negative, because we're going to assume it's positive, or we're going to do the calculation as if it was positive and then apply the 1 over the result at the end if the original 1 was actually negative. So let's define a variable to keep track of whether or not our exponent is negative. So we're going to say is negative is going to equal to whether or not n is less than 0. Obviously that would mean that our power is negative. Then, like I said, we want to work with a positive power because that's going to make our lives a lot easier. So we're just going to say n equals the absolute value of n. And the reason that we have the is negative is because now we'll get rid of the negative if it was, and there's no way for us to undo the absolute value. So we need to store it up here in this is negative so we can apply it later on. Now what we need is some sort of memo dictionary to store our intermediate results. So we're going to say self.memo. It's going to be equal to our dictionary here. And we're going to say the result is going to equal to whatever self, and we're going to define a fast power function. So we're going to say fast pow. We're going to pass in xn, and we're going to, that is going to be the result of x to the n. And remember, at the end, we need to just return the result if it's positive. If not, then our result is just 1 over whatever the result was. So we're going to say return 1 over res if is negative. Otherwise, we just return our result. Okay, so now we need to define the fast power function. So we're going to say def fast pow, and this is going to take the base, and it's going to take n. So we're going to say if n in self.memo. So basically, if we've already calculated this power before, then let's just return it. We're going to say return self.memo of n. We don't actually need to do anything. Now, remember that we had two base cases. The first was if n equals 0. Remember that any number raised to the 0th power is always going to be 1. So we're going to say if n equals to 0, we're simply going to return 1. And then if n equals to 1, remember that any number raised to the first power is always just going to be whatever that number is. So 2 to the 1 will be 2, 3 to the 1 will just be 3. So it's always just whatever the base is. So we're just simply going to return x, which is our base here. Otherwise, the value for our n is going to equal to self.fast pow of x. And remember that we divide the power by 2 each time. So we're going to use integer division here to take care of the case where we have odds. So we're going to say self.fastpow x times n over 2, and then we're going to multiply self.fastpow x n divided by 2. So remember, when we call this function, this one will evaluate first, and then when we go into this one, our value will already been stored in the memo because this one will have fully evaluated. So this will just return quickly from the memo, and we don't actually have to compute that value. Now remember that we still need to take care of the fact that if it's an odd number, we need to multiply by the base to the first power, and if it's even, then we don't have to worry about that because it just divides evenly, and we need to just worry about the odd case. So we're going to multiply by x if our current power modulo 2, basically if it's odd, we need to multiply by x, otherwise we just want to multiply by 1. And we multiply by 1 because any number multiplied by 1 is that same number. So this is the one case is going to be when we have an even number because this is going to divide evenly. Multiplying by x is when we have an odd. So now all we need to do is simply return self.memo of n, and that is it. So let's just run this, make sure we haven't made any syntax errors. Cool, we haven't. And we will submit this, and it works. Cool, so what is the time and space complexity? Well, like we touched on earlier, the time complexity here is going to be big O of log n. And the reason it's log n is because we are cutting down the amount of computations we need to do by 2 each time by having basically our exponent by 2 at each step. So this means that we're going to be doing a log operation. And what is the space complexity here? Well, we have this memo dict which stores our results. And remember that we're having our problem space down by 2 each time. So we're also going to be storing log n intermediate results in this self.memo dictionary. So our time complexity is going to be big O of log n, and our space complexity is also going to be big O of log n. So that is how you solve Leetcode problem number 50, pow x to the n. This is a little bit of a weird one. If you don't remember your exponents, you might run into some trouble. But I think that once you've seen a video like this, it's really easy to just pretty much memorize this one. And it's not even one where you have to worry too much because it's pretty intuitive. Once you've seen the code once, it's really easy to repeat and kind of talk through. It's not that bad, but if you've just seen this for the first time, you're like, what the hell? How do I do this? How is it log n? But once you see it once and you see how you can decompose it by 2 each time, it's pretty straightforward. So nothing really to worry about. If you get this question, you should now be able to fly through it and land that job. Anyway, if you enjoyed this video, please leave a like and a comment. It really helps with the YouTube algorithm. I took a pretty long vacation recently and I haven't been posting videos, so I definitely need the help in the algorithm because I'm probably D-ranked right now. If you want to see more videos like this, please subscribe to the channel. I'll have a lot more content coming out in the future. Otherwise, thank you so much for watching and have a great rest of your day.